Hello everybody, my name is Artem Andreev and today we're going to be discussing a topic of solving logs equations, which is in book chapter 4 section 5. But before that I want to start off a little history crush course to talk about logarithm. So logarithm was invented there was a dude named John Napier. He was born 1550. Here he is. And he was a Scottish mathematician. He had a big interest in astronomy. It required him to do big calculations, which he didn't like to do. With the use of logarithm, he developed ideas that shortened the time to do long and complex calculations. However, his approach to logarithms was different from the form used today. Fortunately, a London professor, Henry Briggs, who was born in 1561, which is just 11 years after our hero, his name is Briggs. His name is Napier. Let's put it aside. Briggs. Okay. So he became interested in logarithm tables prepared by Napier. He traveled all the way down to Scotland, where Napier was, to work together and develop a table of logarithm that we are using, that remain in common use until the advent of calculators and computers that we are using today. And the common logarithm are occasionally also called Brigsian logarithm. Okay, so that was a little course, and let's see our examples and work with our 3 examples. Okay, so before we start, I want to show you a quick note where all 6 laws of logarithm are. We are going to use all of them eventually, so please copy it down because it's all these 6 laws are very important. Okay, so let's do first example. It'll be number 3 from page 318, and it says tan the power of x equal 25. Okay, so first thing I see here is I need to find x. Here we have to solve for x, so I'm gonna take a logarithm of each side. So that's what I'm gonna do. A logarithm tan x equals 25 ln. Yeah. So that's what I did. I brought down the exponent. Actually, that's what I'm gonna do. I'm gonna bring down the exponent. So first step there was take ln of each side. Step 2, bring down exponent. That's very important. Bring down exponent. Okay, that was, and third step, we are just solving for x, so that means x equals ln 25 ln 10. And so yeah, step for x, I'm not going to put it. Using calculator, we have to put ln 25, make sure it is in parentheses, and divided by logarithm of 10, and we will have like approximately 1.3979, and that's our final answer. So yeah, that's how it is. Okay, I'm gonna do a little cheat sheet. Same page but different number. The number is 39. Yes, 39. So let's do it. 39. Oh, I mean 31. Yes, sorry. 31. Page 385 is the same from textbook. Okay, so what do we have? It says e of 2 of x. Yeah, you can see. Yeah, it's if 2 of x minus 3 e of x plus 2 equals 0. Okay, first thing coming to my mind. Why don't we? So we have 2 of in power of 2 2x. So why don't we just let y equal e of x? So y squared minus 3y plus 2 equals 0. That's easier, right? We can, and we see it's just a basic example of factoring. So that's what we're gonna do. Y minus 2 and y minus 1 equals 0. Yes, that's what we did. And 0, then we can use 0. Yeah, I'm gonna put step as well. So there will be step 1, actually just step factor. Second step would be, second step we would use 0 product property. And that's what I mean by that. We're gonna have both parts equal to 0, so that will be like that. And this one will be y equals 2, and that will be y equals 1. Okay. And then we just substitute. Substitute step 3. We're gonna substitute e of x. So that'll be e of x equals 2, and e of x equals 1. Yeah, so you can see. Yes. And then we have to apply ln to each side. I mean, apply logarithm to each side. So that would be apply logarithm. I'm going to put step 4 so you can see what I did here. Apply ln for each side. Okay, so that's what I did. I'm actually, that's what I'm gonna do. ln e of x, ln of 2, I mean not power 2, just 2, and ln of e of x equals ln 1. I simplify. Next I just simplify. Step 5, simplify, and that'll be x equal ln 2. So yeah, so that would be the answer. And the other one would be x equal ln 1, or since we can use the law number 5, which says log of a equals 1, so therefore, actually log of 1, I'm sorry, log of 1 equals 0, that would be log 4. So therefore x will be equal 1. Yes, okay, so now like that. So this is our final answer. 2 final answers. ln of 2 and x equals 0. Okay, and the last we have is number 43. I'll put it right there. It's still page 318, and let's do it. 4 minus log of 3 minus x equals 3, and the first thing I see here, we have to subtract the 3 from both sides, and that would leave us with 1 equals log of 3 minus x. And then I see here, and I want to get rid of log. What am I gonna do? I'm gonna exponentiate both sides with a base of 10, and that's what I mean by that. I'm gonna multiply each side by 10, so I can cancel out the log, and so that would be just 10 equals 3 minus x, and then just solve for x, and that would be x equals -7. That's it.